Here are the answers to your 5 a day. Okay, so today we're going to be looking at solving equations over the complex numbers, and more specifically, how to solve quadratics with a negative discriminant, which up until now you would have written no real roots or no real solutions. So let's start with a simple one. X squared plus 9 equals 0. Start by subtracting 9 from each side. Then I'm going to square root both sides. Because we're solving an equation, we need to remember that we need to consider the positive and negative square roots. Split up the surd part. Well, it's not a surd. Split up the square root part and rewrite in terms of I. So the solution to x squared plus 9 equals 0 is x equals positive 3i and x equals negative 3i. It's really important that you write out each of these steps while you're getting used to this process. In the future, it might be okay to skip a couple of these, but for now, make sure there's lots of lines of working. Okay, so here we've got a slightly more complicated quadratic. We've got two options for solving this. Which are the two options that you have for solving many quadratics? We can complete the square, or we can use the quadratic formula. Let's look at completing the square for this one. So I'm going to rewrite with a squared bracket, with the number being half of the x coefficient here. So that gives me x plus 3 squared. Now, if I expand that bracket, I have plus 9 as my constant. I want plus 25, so I need to add on another 16, and that's equal to 0. Now I can subtract 16 from both sides. Square root both sides, remembering I need to consider the positive and the negative square roots. Subtract 3. Then I can separate the negative and the 16 in my square root, and I can simplify that. So the solutions to this equation are x equals negative 3 plus 4i, x equals negative 3 minus 4i. When our x term is even and the coefficient of x squared is 1, then completing the square is usually the quickest method, but it depends how familiar you are with each of the steps. Alternatively, we can use the quadratic formula. We know the quadratic formula always works. So this is our formula. Our A is 1, B is 6, C is 25. Be careful with negatives. We don't have any negatives here, but you might do. So substitute the values in. Calculate the discriminant. Split the negative 64 up. Simplify. And then divide by 2. So the solution, as before, is either x equals negative 3 plus 4i, x equals negative 3 minus 4i. When the x squared coefficient is greater than 1, so it's a non-monic polynomial, or non-monic quadratic, sorry, or if the x term is odd, then probably the quadratic formula is easiest. But it's down to personal preference. Okay, so now pause the video while you work through question 1. Be careful, remember that to solve a quadratic, it needs to be equal to 0, using the quadratic formula or completing the square. Here are your answers. And obviously you need to be able to do that without the CAS, but the CAS can do it for you. So it can both factorize a quadratic. Obviously you need to be in complex number mode, I showed you how to do that in the previous few lessons. And we can also solve, but you need to use a complex solve, not just the normal solve function that you would use for other equations. Let me know if you have any questions. Thank you very much.